This tractor requires a really large step to get up onto it. Hello and welcome everyone. I purchased this white 2-65 tractor about 6 weeks ago, and I did have a video on that as well. At some point in this tractor's life, it had a loader put on it, and the original step it would have had on was removed to accommodate the frame. There was never another step added to the tractor, so it's a pretty high reach to get up onto this tractor and not very comfortable. In this video, we're going to measure, design, build, and install a step onto this tractor to make it much easier for getting on and off. So the step amount is currently about 31 inches from the ground to this platform here, and that's way too tall in my opinion to get onto the tractor. It would have originally had a step, I believe, mounted here and then another bracket underneath, and it would have came down around here approximately. If the tractor did not have a loader frame on it, the original factory mounted step would have looked like this and been mounted here. With this loader frame installed, there was no room for it apparently. Previous owners, I guess, didn't feel the need to put another one on there. And I don't even have that step any longer, so we're going to measure and make a custom fit step for this. But first, let's go and measure some of the other tractors I have just to see how high their step height is. This particular tractor is an Chalmers 175, and its step height is about 27 inches. And this particular tractor is an Chalmers 5050, and that also has a step height of about 27 inches. It's a little hard to see here with a loader frame in the way and its hydraulic holes. And then on this particular tractor, which is an Chalmers D12, it's also near 26 inches. So after measuring the other three tractors, they were all close to 27 inches. And this is 31 to the top deck here, so it's only 4-inch difference, which doesn't sound like a lot, but it sure feels much higher when you're actually stepping on it. So in my opinion, the 27 inches is still a pretty tall step, especially the older you get. So what we're planning on doing, I'm going to measure some features on the tractor underneath and see what kind of clearance the tractor itself has as you are riding over something. And then we're going to determine how tall to make this step. We may make some compromises for various other things as well. So we're looking underneath the tractor here. This is the center pivot for the four-wheel drive differential area. And that hangs down from the ground to here about 16 inches. And then if we look over to here, you can see the actual transfer case that would turn the four-wheel drive on and off here. And that sits up about 15 inches. And then look a little further back is the drawbar carrier, and that's somewhere between 15 and 16 inches as well. So I'd like to at least maintain 16 inches of ground clearance. Maybe even a little more. And if you divide the 31 inches in half, that gives you 15 and a half. So if I made an equal step from here to here, that would be 15 and a half inches. I'm going to go a little higher than that. My thoughts are I may have this come about 17 inches off the ground, which it's not quite half, but it's pretty close, and it gives us just a little extra ground clearance if needed. And after giving this some thought, instead of trying to attach it to the actual tractor itself, like there was originally attached to the step. Now the step, you can see, flops around quite a bit. There's rubber mounts on there that need to be replaced. But I'm going to attach it to this loader frame. And what I believe I'm going to do is actually weld a bracket on here, maybe a right angle bracket with some holes drilled through for bolts. This part of the loader mount here, I'm just going to drill some holes through here so I can also mount a bracket. I'm going to have 2 vertical brackets coming up and down, one here, and then one by the other bracket I'd like to weld on. I generally don't like to weld on stuff, especially to the tractor. I wouldn't weld it onto the tractor, but being that this is part of the frame, I'd feel okay welding onto there, and if I had to remove it for some reason, you could cut it back off again. So after thinking about this a little more, I believe I am going to have two vertical pieces of 3/8 wide metal running up and down. and they're going to come out about 6 inches, and we're going to be about 16 inches wide. So 6-inch depth, 16-inch wide. The top of the step about 17 inches off the ground, maybe 18 inches. So 16 inches wide shouldn't interfere with this tire at all. It'll be still higher off the ground than what the center pieces are in the tractor. As far as the actual horizontal step itself, my thoughts are now I'm going to cut some 1-inch wide strips. I have a big plate of 3/16 metal, about 18 inches wide. I'm going to cut some 1-inch strips, probably 6 of them, have them spaced approximately 1 inch apart, and then cut some serrations into them. And then we're going to weld them on. I'm going to show you some of the cutting of that metal, and then some of the machining as well, and then fabricating, and then probably some of the welding, and then we're going to paint it and then do a final install, and we'll see how it works. So I created a rough drawing of the vertical pieces of steel we got to have for our step. It's going to be about 6 inches wide, 10 inches tall. There's going to be 3 holes through it for mounting, and it's going to be about 3¼ inches here, and then it's going to widen out to 6 inches, so it's coming down on an angle. Did not draw the crossbars joining these 2 plates together. These will be the end plates. What I am going to do is I'm going to draw it up on CAD, and then we'll just view it there. But this is just kind of a quick reference I can look at now, and I'll have these dimensioned out, so when I go to drill them, I'll know we got to have those holes. Here's the steel we're going to use here. We've got a piece of 3/8 plate. These are where we're going to make the end plates with that run up and down. And then this is 3/16 plate here. That's what we're going to make the step, the horizontal bars out of. We're going to rough cut all this out on the bandsaw. And then we're going to take it over to the milling machine and machine it to the correct sizes. This would be a great job for a CNC plasma cutter. You could save a tremendous amount of time versus cutting it on the milling machine that we're going to do. You could basically cut it right to size. You could eliminate the bandsaw. You could eliminate most all machining. But we don't have a CNC plasma cutter, so we're going to use the older methods of cutting it on the bandsaw and then machining it to size with a milling machine, which will turn out very nice, but it would be much faster with the CNC plasma cutter. Probably won't show all the steps and every piece that we cut out on the bandsaw. I'll just show a few examples, and then I probably show an example of machining each plate too. Here's our step drawn up in the CAD system. You can see the angle bracket here in a different color gray. We've got to weld this to the frame. And I believe I mentioned earlier I was going to have 5 or 6 of these step bars. After looking at it, I decided to reduce it down to just 5 of them. Here we're cutting off the 1-inch strips. I have this 1/4 inch plate of steel here. It's about, I think it's about 17½ inches long. We're gonna cut 7 of these 1-inch strips off, and we've got to cut them down to about 16 inch. So this bandsaw is an older Kalamazoo bandsaw. It has a little larger cutting throat here than some other bandsaws I've seen of this era. You can cut up to 24 inches here, which is kind of nice. And at one time I fabricated a drip system here out of just some various components. This is an old lubricator. There's a valve put on here, then I just created a piece of aluminum. I can clamp it to the arm of the bandsaw here. I can adjust it. It just drips. You open the valve, you just set it to however fast you want it to drip. And I just have just coolant added in here, so it works quite well. It's not the most efficient way of cutting this 1-inch strip. If we had a plasma cutter, it would be much faster, but I could set this up and let it run and do something else while it's running, so it works out okay. So now with our step platform pieces cut out in the bandsaw, we'll have it set up on the milling machine. With all the pieces we cut off, we'll have them stacked together so we can cut all of them at one time. We're taking a roughing cutter here, and we're going to true up both sides of this and then eventually on the ends. After getting the rough size of these steel pieces here cut out with a roughing cutter, I then switched to a finishing cutter, and we could take them to the correct size and leave a nice finish on them. Here we're set up to do the two end plates. We have them set up on the mill, stacked on top of each other. What I'm doing is I'm gonna make it a cut along this side. I can cut along this side and this other end here, so I can get 3 cuts in one setup. And then so we're gonna get it to length, or yeah, we're gonna get it to length. We're gonna machine this side, flip it around, and we'll machine the other side and get it to width. So I was going to machine these 3 sides. I've machined these 2 now. Then I was going to just shave off this end and get it to length. However, I didn't realize there was almost an inch of stock left on there. So I really need to saw that off. What I'm going to do is reposition these clamps to the end and try and not move my location here. And then I'm going to machine the other side to width. And then we're going to put it in the saw that off, and come back and machine it to the finished size. So we're just finishing up the cut on the back side. Now we'll have our width established. And while it's clamped up here, I'm going to go ahead and drill in the mounting holes. And then we've also got to cut this plate down, cut an angle on it. So I'm going to drill like a centerline hole where that intersection has to be. On our drawing here, we're going to now put in these 3 holes, and then we're going to put in a hole here. This is an intersection point of where this angle meets this straight edge here. So you see I've got a 0 marked here. This edge, we're going to pick up this edge here and this length here. We're going to call this corner 0. Now in the milling machine it's sitting this way. So I just have some coordinates written down here in X and Y dimensions of where these holes are. These are going to be 3/8 of an inch holes, and then this intersection point is going to be a 3/4 inch hole. So we're going to put those holes in now, then we're going to pull that back off the mill. We're going to saw this end off and throw it back in the mill and machine that straight again. So these holes are for the mount as it mounts to the loader frame. I'm going to have to make another angle bracket for one of these vertical step brackets here. So we're going to pick up these 2 edges here. We're going to reference our 0 corner here. So this device here is called it's either called a wiggler or an edge finder. If you see this here, this moves around. And you spin this about 1,000 RPM, and you'll move this up to the edge, and when it centers itself, it'll kind of knock off to the side a little bit. And I'll try and get that on camera. And once it does, you're 1/2 the diameter away from the center line. So this is 0.2 inches wide, so half that is 0.1. So once we touch off, we got to move over 0.1 inch or set, you can actually reference that on this digital readout here, and that's what we're going to do. So I'll try and give a view of this edge finder in action. You can see how the end of this is wobbling right now. Once we move this to the edge, you're going to see that wobble come out of it, and then it's going to kick off to one side just a little bit. Sometimes that's hard to see, but we're going to move the table in. Okay, we're just starting to make contact. See how it's getting truer and truer. Slowly moving it in. Okay, you see it kicked off to the right a little bit. We're going to pull that out. We know we're 0.1 inch from the edge, so we're going to go, we're in the Y direction. We're going to select Y over here, 0.1, enter. So now it's saying that it's 0.1 of an inch away. So if I move this to 0, center of the spindle on the edge of the part. So now we're going to do the same for this edge over here. And then we'll have our X and Y 0 established. So now we have our 0 corner established. We put a center drill into the drill chuck here, and this is what we're going to use. We're going to spot drill the locations of all our holes. So the tool bit in the drill chuck now is called a center drill. It just will create a pilot hole for the drill bit to get started in there straight. With our 0 corner of the part reference, we're just going to put all the locations into the digital readout for both center drilling and our drilling. With this brush here, we're going to put a little bit of cutting oil onto the center drill and then onto the drills when we drill those holes as well. So now we got to take this over to the bandsaw. I'm going to cut off, I don't know, maybe 3/4 of an inch or so on this end. We're going to set it back up in the mill. We're going to mill these plates to the finished size length. And then I think while it's sitting here, I'm just going to maybe put some red layout dye on. I'm going to scribe a line where we got to cut that off. And we also have to make an angular cut going across this way. And we have to make another cut coming in this way. So I'm going to scribe some lines on there so we know approximately where we need to be as well. We've got some red dye. I'm just going to spread that on this plate approximately where we're going to scribe the line. Just makes our scribe line show up much easier. So we're going to quickly scribe the lines on these plates. Then we're going to pull it off the mill, bring it over to the bandsaw, cut it to length, and then load it back on the mill and finish machining these plates. We've got the plates set back up on the milling machine. Or clamped back down. Both plates are together. I had dowel pins in those holes we drilled to keep it in alignment. We're going to come back and machine off the edge here, get it to length. But first, I'm going to take the dial indicator here, sweep around this hole. So we're going to find the center line of that. We're going to record it on the digital readout. Then I'm going to machine this off. We're going to come back and we're going to cut this leg of the piece off here, and then we're going to have to rotate it and then cut along this line here, and then we'll have the shape of our vertical brackets. Here with this test indicator, I'm just going to drop it down into the hole, and we're going to swing it around until it's 0, and then we're going to call that 0 on our readout and use that to orientate our cutter path. Now with the finished cutter in, we're just going to cut these plates to length. Then we're going to measure it with a dial caliper until we get it to the right length and move on to the next step. So this cutter is turning clockwise. And you see I started from this end here and moved to that side. That's called conventional cutting. And if I were to start on that side where the cutter is now and move this way, it's called climb cutting. Because of the rotation of the cutter, it tends to want to climb on the work. Now that'll leave you a little better surface finish, and sometimes if you're taking a slightly heavy cut, this cutter will tend to want to climb on top of the work, and sometimes it will pull it in a direction and bad things will happen. So on a manual milling machine, you want a conventional cut when you're taking a heavier cut. Now with our two plates machined to length, we're going to switch to a roughing cutter, and we're going to machine the straight part of this here up to the hole we drilled in there, that 3/4 inch hole. And then we're going to have to angle the plates and then machine along that scribe line to finish cutting off the remaining part of the plate. So we'll have our angle on it. Here's the cutter we're going to use. It's a 3/4 inch. It's made out of high-speed steel. It's a roughing cutter, so you've got these serrations in here. You can tend to take a very heavy cut. Also known as corncob cutters. Right now we have the roughing cutter centered over that hole. Now these cutters tend to cut a little bit oversized, so we're going to move it back in this direction a little bit. And as we feed it down, it's going to be cutting off the side of one of these holes. So we just want to make sure we have enough finished stock on there to make a nice clean cut. We're going to get the coolant mist set up. We're just feeding it down into the workpiece, and we're going to, with a power feed here, we're going to move it in the X direction. We're trying to take a full depth and width of cut. We're feeding it in really slow. The readout's going about as slow, or the power feed's going about as slow as it can. So we're going to take this finishing cutter. It's another high-speed steel cutter. We're going to put it back up in there, get it on our hole center line. And now this cutter's ground a little bit undersized, so we're gonna go right to 0, 0. Then we're gonna make a pass, and then we're probably going to move it over to get it to blend in. Okay, we've got this area cut out now. It blended off nicely with our hole we cut in there. So now we're going to unclamp it. We're going to have to rotate this. We want it to get to line up with this line here. And I believe that was about at 21 degrees. As this is being cut, I was trying to think of how we're going to line this line up in the path of travel. So I first thought about taking a protractor and trying lining up this edge here with this part of the table, which would work. It'll get us close. However, being that we got to have a gap up here, it's a little hard to get the protractor in there that I have. Another device we can use is called a sine bar. Now that's probably way overkill in accuracy for what we need it for, but I think that may actually work easier. And we'll grab that in a minute. We're gonna line this edge up to this edge. Well, and our sine bar is a precision bar that'll tilt at an angle, and well, we'll get into that in a minute, but I believe that's what we're going to try. So we're going to set the angle of our plate here with this device here. It's called a sine bar. Now this was something I made in high school, not in the high school shop class, but in, well, at the time we called it the Skill Center. I took like a 2-year machine shop course there in my junior and senior years for half days. So this is one of the projects that we had to make. Our local high school no longer had a metal shop. That was closed down a couple years before I got in there. So what this device does, well, let's back up a little bit. If you took high school geometry or any geometry class, you probably heard of sine, cosine, and tangent. That's a way of figuring angles from a triangle. So we know our angle here is 21.448 degrees. Now, what we're going to do is we're going to take this bar, and I'll show you that in a minute. We'll get back over to the milling machine. We're going to tilt it on an angle on that 21 degree angle, but we have to create a stack up of blocks, which are these blocks over here. They're called either gauge blocks or Joe blocks. That was the original name, I think. And what this bar here does, this is, if you see the center of these round tubes on here, these are hardened steel right here. From the center of these hardened steel tubes, it's 5 inches. Precisely 5 inches. So we're going to use that in our geometry equation. So we have to determine how far we want to tilt this sine bar here. So we know our angle is 21.448 degrees. And from the calculator, I determined that the sine number is 0.366. So we want to take the sine number, 0.366, times 5. That's the distance of our sine bar. And that's going to equal 1.828. We're going to take these blocks here and we're going to come up with a combination of 1.828 inch. So we're going to start out, we're going to find the inch. Here's a 1-inch block. Now we're going to, let's see, we're going to take a 700 block, 700. And then we're going to get the 828, we're going to pick a 128 block. So all three of these stacked together should equal 1.828. Just to verify I have the correct stack up here, we're going to measure it with a caliper. So yep, we're at 1.828. What this will allow us to do is to tilt this sine bar up on that 21 some degree angle, and then we're gonna run like a parallel against the mill table to line that up. So we'll go over to the mill now and show you how I'll set that up. So back at the milling machine, we're gonna put our sine bar up against the edge of our plates here. We're going to take our stack up of gauge blocks. We're going to put them here. Now I've got to find something flat. I'm going to lay on the table up here and we're going to push this all tight to that. Okay, I got this flat bar of steel. I'm just going to set that up against the edge of the table. We're going to push all this up tight. Okay, so what's happening here, the sine bar is up against our plates. This round piece is resting up against our metal stop here. And this round piece is up against the gauge blocks, which is up against the metal piece here. So we're going to just remove this. We're going to clamp it down and we should be set to go. Okay, so we roughly found the center of the hole that we had here with the indicator. It was hard to get it perfect because we had cut some of that away. So we're going to put the roughing cutter back in. We're going to move it up close to that scribe line, and we're just going to take a light cut all the way across just to see if we got our angle close. And then we're going to drop it down for the full cut and cut this chunk off here. So right here, I'm just taking a skim cut across the workpiece just to verify that we have this block tilted at the correct angle. Okay, well, I don't know if it shows up well on camera, but I ran a light pass near the scribe line. We're just away from it a little bit. You can see it's consistent all the way across, so we know we have the correct angle. So we're going to lower the cutter down, and we're going to try and take that all off in one pass, and then come up with a finished cutter to clean the rest of that wall up. I must have forgotten to hit the record button here, so I don't have video of the cutter running across these plates here. So we've got it machined off. I didn't film the finished cutter coming in there, but it looks quite nice. So we're gonna pull it off the mill. We're gonna run a little right angle grinder around, deburr all the edges, and move on to the next step. So here's where we're at on the project. We've got both these plates cut out. I got them deburred with a right angle grinder. We have our holes in here. This bracket here is going to attach to the horizontal part on the loader frame. And this part here is going to attach to kind of where the horizontal and vertical part come together. So there's a flat piece of steel where I can mount this on the vertical area. I'm going to have to drill holes through that. We're going to bolt that. Now this one here, I have to make a right angle bracket. So I've already cut some pieces out and machined them square. What's going to happen here is we're going to have a, okay, I'm going to take these two pieces here, excuse me, like this, and weld them together. And then that is going to sit in here like this. And we're going to weld this part to the loader frame. And then we'll be able to unbolt this plate here. So what I have to do yet is I have to drill the holes through to match this. And then being that we're going to weld this together, I'm going to take a heavy chamfer on this side, maybe like cut it 45 degree, and then on the mating part here. So when we weld it together, we have a nice V'd out area to get a good weld penetration. Another thing we got to do, I have these machined to the correct height here. I do have to shorten them up a little bit, but we're going to weld. Okay, so this is going to be out like this. We're going to weld two of these on both sides like this. And then the other three, we want to fit inside of there. So what I was going to do is I'm just going to cut them to length so they fit down inside here. Now what I'm going to do is I'm going to cut 3 grooves in here where these horizontal pieces have to go on either side, so that when I fit them in there, they can kind of fit up in a slot, and then I'll just weld around them, and it just makes it easier to locate them. It takes a little more time cutting the slots in there. But so we're going to go to the mill, drill the holes through this plate, and then on the mill we're going to also cut those slots in there, and then we've got to cut these things to length. And then we're going to go over to the welder, weld it together. We've got to drill the holes through the loader frame. Then we got to weld our bracket onto the loader frame. One other thing I forgot to mention, on these step plates here, 1 and 2, we're going to clamp all of them together. We're going to take it over to the mill. We're going to make some passes through here. I have some of these 5-degree cutters. We're going to cut down maybe 1/8 of an inch, just so you get some nice serrations in there to get some grip when you stand on it. So we've also got to do that. So what we're going to do here is we want to have a good chamfer for the weld. So I've got a V-block set here, and there's a 45-degree V. So we're going to stick this plate here. We're going to hold it like that. And this is not real critical, but we're gonna run a cutter across here and put that chamfer on for that weld. Okay, we got our chamfer machine down there. This is how it's going to be welded together. So we've got a nice V shape down in there to get a good bead of weld there. We've got our angle bracket set back up in the mill here. We're going to drill these holes in. I have them roughly laid out where they have to be. So with this edge finder here, we're going to pick up this vise jaw, so it'll be the edge of the part here, and then we're going to pick up the edge of the part here, and we're going to reference those holes from that location. So we have the holes in there. I just want to lay this one over top to make sure we did it correctly. One thing about using a digital readout, everything should be in the exact location. These holes are drilled right to 3/8, not oversized. You typically would drill like a 32nd of an inch oversized, but in this case we're not going to do that, at least for now. Let's just see if they do line up. Yep, so that's a nice fit. Now we're going to come back and we're going to clamp these plates in the mill, and I'm gonna cut these slots in here where we're gonna put our horizontal runs. So we got our vertical side plates in the mill. I've got it set up. It's on the center of the plate now. We're going to cut a 1/8 inch deep, about an inch in that direction. And we're probably going to take that in 3 passes. And then we got to move over 1.5 inches on either direction and do that. And then grab the other plate and do the same there as well. Okay, so we got the slots cut in there on this plate. We're going to go ahead and do the same to the other plate. These slots are going to be just a little bit wider than the pieces that have to fit inside there. I didn't have the right size cutter, but that's okay. That'll work out. The horizontal step bars are being cut off in the bandsaw now. Then we're going to take them over to the milling machine. We're going to cut some serrated slots in there for extra grip. Now I have all 5 of the step bars clamped together and then clamped in the milling machine vise. This vise is about 6 inches wide, so we're going to have to cut our segments in there and then move it over to the other half and cut those as well. The cutter we're using is tapered at 5 degrees per side. We're going to touch off from the top of the workpiece, and we're going to cut down about 1/8 of an inch. Then we're going to move the cutter over 1/2 inch on the digital readout for every cut. So I experimented a little bit with depths of cut. Ultimately, I ended up going in 2 passes. I cut about 90% of the depth and then came back through and recut the last 10% for a finished pass. And this cutter ended up holding out for the entire amount of slots I had to cut, so it held up real well. We've got 1/2 of it cut now. I'm not going to go, I could fit in one more pass, but that's going to bring us pretty close to the edge, so I'm not going to do that. I'm going to deburr this while it's here, then we're going to shift this over. We're going to pick this edge up and then cut the other half. So I'll bring it back at the end of that one. Well, here's the finished product. We got this thing cut all the way across. There's 5 of these plates bolted together. I still need to deburr them all. I'm gonna put this in the bench vise and take the little right angle grinder and kind of just put a good chamfer radius around all these and just take the sharp edge off them. And then we got to get it clamped up to the uprights, and we'll start welding it together. So guys, here's basically what our step is going to look like. I just have them laying loosely on the bench here. We still have to weld it together. A couple things I need to do. On this upright here, I'm going to have to, I think, cut out a little notch here, because where we have to bolt this, there's two pieces welded together, and there's a weld seam in there, and I need to clear out for that. Also, of course, I have to make this bracket yet. I have to weld that back together, and that is going to go over to here. And then once that's welded together and it's fit, we're going to weld that to the frame. Another thing I want to do, take this edge here and we're going to put a radius on it, and I'll probably do that before we walk down to the other building to weld it together. I may put like a, I don't know, 3/8 of an inch radius on here. We're going to do that on the disc sander. And just a couple other things I wanted to show you here. It's not related to this project necessarily, but it is for the tractor I'm working on. I machined up some new pins just to replicate an existing pin. This goes down near the drawbar area. And then these 2 pins here are basically a shorter version of this. This is the original pins. These 2 are both original pins. This is going to go on the 3-point arm, the one that links the arm to the lift arms. So I'm replacing both of those. That had something else retrofitted in there. And then a PTO cover, or PTO shaft cover. This was actually made out of, repurposed a Massey Ferguson 202 forklift axle. So I had to hollow it out. And then these threads on here, they're 50mm metric threads. I ended up cutting those on this lathe over here. And then I just machined some slots in here so you could put like an adjustable wrench on there. So I have not painted this yet. I just want to make sure it fits correctly before I do. I have threaded it on there. I just want to make sure once the PTO shaft is actually spinning, that it clears. So I found some, no, I didn't find it, but a local paint shop mixed up some paint to match this color. It's a variation of a charcoal gray, but they did a really nice job of matching it. I took a body panel part from the inside where it had good paint on, and they matched it. So they made a spray can. So I'm going to use that for other various parts. The step here, we're going to end up painting probably a satin black. We'll take care of this radius now. Then we're going to go down to the other building where the tractor is and the welder is, and we'll start welding things together. So here's what I was talking about. We have to clear out for a weld. There's a weld seam here. This plate is gonna fit in. We're gonna bolt that on there. So I'm gonna notch out an area about 3/8 of an inch this way, and then about 3 inches this way. So when we bolt that up there, it clears that weld. So what we're going to do is I'm going to take some of this red layout dye. We're going to put some dye on the corners of the areas we want to put a radius on. And then I have this radius gauge here. We're going to set that down. And we're going to take a scriber, and we're just going to scribe where those are. And then we're going to take it over to the disc sander and just sand it till we meet our scribed line. So we're going to set that up in the corner. Run our scriber around. This red dye just makes this line that we're scraping on there stand out a lot better. Let's take you in a little closer. So you can see our scribed line here. We're going to take that over the disc sander now and sand it down. So there, we've got our radiuses ground onto the steel here. So the next time you bang your leg or your knee on it, it won't hurt quite so badly. And we got to take this one over to the mill now. We're going to cut that notch out to clear that weld. I probably won't show that, nothing too exciting there. Now that we've got this clearance machined into the plate here for our weld, we're gonna bring it over to the other barn. We're gonna clamp this in place, or try to clamp it in place. I'm not sure if I have enough room with the clamps I have. Then we're gonna take, this is called a transfer punch. These are made from 9/32 of an inch up to a 1/2 inch in increments of 1/32 of an inch. They're basically just designed to have this plate in place, and we're gonna tap it lightly. You don't want to, these are not designed to hit real hard. And I don't know how well it shows up, but there's a point on here. And so it's typically you put that in all the three locations, remove your plate, and then you would come in with a larger punch and hit it a bit harder to put a good size witness mark in there, and then start your drilling. But we're going to still transfer punch, and we're going to try and leave it clamped into position, and then just go right in with a 3/8 drill. I'm going to start it a little bit, and I may come back with a smaller drill, a pilot drill, just to get it started, just so it goes through easier. And then we still have to weld this together, our angle bracket. So I'm going to clamp this in this angle plate here. We want to have a nice square fit, so when we weld it onto the frame, and you know, it's good and square. So you can see how it's V'd out there. We're going to fill that in with weld, and then probably some of the weld will be sticking out. So we're going to come back and machine that flat. And then after that's done, I'm going to mount it internally into here, and we're just going to weld the bead to the inside. Actually, it goes like this. And then we still have to weld this onto the loader frame itself. So we're going to do all this before welding these step bars here onto the end plates. So we're going to take the old reliable Lincoln welder here. This is a stick welder and a TIG welder. And we're going to try and weld this angle bracket together here. So my welding skills are probably a bit rusty, so we'll see how this goes. For welding this angle bracket together, we're just going to use the stick welder, but when I go to weld the step stringers together, we're going to probably use the TIG welder portion of it. Ideally, I probably should practice a little bit here, but we're just going to go right for it. Yeah, it's all going to get covered up anyhow, so if I really mess up bad, it really doesn't matter, as long as it don't break off. Here we go. It certainly wouldn't win any. It certainly wouldn't win any welding awards, but it's going to be okay. So we're going to take this plate now. We're going to clamp it onto here. It looks like we have enough clearance milled out of there to fit this bracket on there. So I'm going to spend a little time getting this clamped in true and straight, and we're going to then try and drill these holes through. We got the plate clamped to the tractor frame now. We're going to try and drill these holes through. We're going to use a corded drill here. We don't use those very often anymore, but for heavier drilling, it's sometimes just nice to have a little something with a cord. One problem we may have here, when I get to this hole here, the drill is kind of close to the frame. Well, I could make it work. I may switch to a cordless drill. I think it has a little narrower body to get in there better. Earlier I mentioned using transfer punches to transfer these holes into this plate, but ultimately it wasn't really needed, so I didn't do it. Okay, so I'm just getting the tip of the drill started in there, and then I'm going to switch over to a smaller drill bit, because it's gonna take a while to press this 3/8 drill through that. I think it's a 3/8 inch thick plate. So I switched to a 3/16 drill bit. I got it started a little bit with a 3/8, and I just think this is going to be a little quicker here. We've got one hole drilled all the way through. We're going to put a bolt in here. And tighten that down, and then just so we don't lose location in case the plate shifts around a little bit. Okay, so we got all 3 holes drilled through the frame here. We're gonna pull that back off, and then we're gonna weld the step stringers on to both vertical side rails here, and then we're gonna have to position the other bracket on over here. We're gonna weld that on. Okay, guys, we're back by the welder again. We're gonna try and TIG weld this time. If you can see through all the clamps I have here, I do have 2 of the outer rails for a step here. It's clamped on. I have some right angle angle plates or supports to hold it in place. So I'm going to end up flipping this on end. We're going to come with a TIG welder. We're going to weld these ends, and then probably on the top and on the bottom. And once we get those welded in the 4 corners, we're gonna come back, and we gotta fit the inner pieces in, and then we're gonna come back here again and weld those in. Hopefully the old Lincoln works well today. It's It's really cold in here. I do have heat, but I don't have it on right now because we're going to be in here, in and out. So if you see, I got some cardboard in front of the welder here. There's a fan that blows a lot of air out. And when you're TIG welding, sometimes it affects the gas. There's gas flowing through here, and it'll sometimes direct it away from where you're trying to weld and give you a bad weld. So this kind of deflects the wind coming out of there. Well, we've got the two outer rails welded on. One nice thing about doing it with a TIG welder, you don't get any of the splatter, and you can get a really nice weld. While you can get a really nice weld, it is definitely slower than either arc welding or TIG welding, or excuse me, MIG welding. But it allows you to get a lot better control of it, and you can weld thinner metals as well. So I didn't really explain TIG welding before we started. Here's your welding head, and in here is a piece of tungsten carbide. You can take this out, and you sharpen it to a point, and then you basically hold it by hand and you feed the rod in. Now sometimes you can just melt the two steels together, and you don't need the filler rod, but generally you do want to use filler rod. Down here, it's kind of like a gas pedal. You can control the amperage while you're welding, so you can, if you're coming to a thin area or an area you need hotter, you can control that as you're going along. And one other thing I didn't say about this torch head, this particular head here, if you see these lines going in, one of them's a gas. I think we're using argon, I'd have to check, but there's also another in and out line for coolant. This head, if you're welding on it for a long time, can get hot. So there's a chiller device up here that circulates, and I have like RV antifreeze in it right now, so it circulates around and just to keep the weld head cool. Well, we're gonna go back to the other workshop. We're gonna fit in our other 3 bars here. I have to mill them a little bit shorter, and we're gonna fit them in the slots, and then we're gonna come back and weld those in. Now it's probably going to be a little difficult trying to get it in between here with this torch head, so it's possible I may have to tack them, and then maybe I'll come in with an arc weld along the sides, but we'll have to see how that goes. So I've got these inner slats cut to length. Got them fitted into the slots here, and what I decided to do, I cut some other little pieces of steel here. We're going to tie them in between. Our step is starting to take shape now. I'm going to put a clamp across here. We're going to bring it down to the welder, and we're going to weld. I'm going to weld across these bottoms in, and I don't know how far I can get in here with a TIG welder. We may just go in as far as we can and call it good. And then really all that we have to do is weld on the L bracket, and then we have to paint it yet. So we're getting pretty close. Well, guys, we got all these slats welded in there now. I got the cross pieces welded in. I TIG welded them on the top and the bottom here, and then on the inner 3 slats here, I TIG welded the top and bottom, which I think would have been fine. But what I did do, and you really can't see it here, I did come with an arc welder on the back side of these and weld that up as well. We're gonna finish bolting that back in, and then we're gonna take this bracket, and I did weld to the inside of this bracket, and I kind of machined it back out again. So we've got to bolt that on here, and then we're going to put this up into position. We're going to clamp it to this frame. Then I'm going to remove the step, and we're going to weld that onto the frame. Okay, with our step bolted on, we're gonna weld it. Okay, so we do just have enough length for the ground, and I have enough length here, so we don't have to move the tractor ahead. Okay, we've got a bead down on the top. I'm gonna try and find a different welding rod. We're gonna try and run up vertically, at least part way. I don't think I'm gonna try and weld along the bottom, so this should be plenty strong. Well, I don't know how well you can see this here. I had some issues with the weld down below. I changed some settings on the welder, and then it didn't come out too bad. So I'll probably touch it up with the grinder a little bit, and we're going to call the weld good. We're going to remove this step, and well, I've got to come back, clean this up a little bit, and then I'm going to, with the step removed, I'm going to kind of mask off an area. I'm going to paint the bracket, and then of course we got to paint the steps yet as well. Our paint is dried now for a couple of days. I also painted the bolts. So we're going to go over to the tractor now, and we're going to bolt this back on and try out the new step. So you can see here too, I locally painted the bracket that we welded on. Then I touched up on the holes that I drilled through the other mounting bracket. Now with the bolts all tightened up, we have our step mounted on there. It looks really nice on the tractor. Let's climb up on the tractor and see how it works. Here's another view of the tractor step outside with a little bit better lighting. Well, everyone, climbing up on the tractor is so much nicer now. I don't know how previous owners dealt with that. It just made a world of difference climbing onto the tractor. We're going to end the video here. Thanks so much for watching. Please subscribe to the channel if you haven't already. I greatly appreciate it. Take care, and we hope to see you in the next video.